Dear students, welcome in this video of projectile motion. In this video, we will discuss about the projectile motion of the particle. And let me explain first about what is projectile motion. Suppose a particle is projected in upward direction, and we know that, and due to the effect of gravitational field, it will come back on the earth. But if the particle is projected other than horizontal and vertical, this is horizontal direction and this is vertical direction, and particle is projected at an angle theta from the horizontal, then in this situation, this is the velocity of the particle, and we can take the horizontal component u cos theta of the particle, and this is the vertical component, we can take it u sin theta, and this particle is moving under the effect of these two components u cos theta and u sin theta, and as the particle is propagating in upward direction, then the gravitational force is moving in downward direction. So suppose we observe at this point, the horizontal component u cos theta remains same, but due to the effect of this gravitational field, the vertical component becomes decreased, and regularly vertical component decrease and horizontal component remains same, and at a point vertical component becomes 0 and only horizontal component remains same. So particle is moving in this direction, and after this point, when vertical component of the vertical component of the velocity becomes 0, particle starts to move in downward direction, and again the direction of the vertical component becomes reverse and particle starts to move in downward direction. However, the horizontal component remains same. So now the direction of the particle becomes like this, and this path of the particle is known as projectile path, parabolic path. And if we discuss about the uy, suppose this is vx, and this is, at this situation, this is vx and this is vy, we can say it, and in this situation vy is decreased, however horizontal component remains same. So we can say vy at this point, suppose this is O and this is point A. So at this point A, vy, it should be, we know that v is equal to u minus gt, and in this situation at this point A, vy is equal to u sin theta minus gt. So vertical component becomes at any point u sin theta minus gt. However, horizontal component vx is always remains u cos theta. So resultant velocity at any point, v becomes under root v x square plus v y square, or we can say that v is equal to under root v x square means u square cos square theta plus u sin theta minus gt whole square, or we can say that it should be under root u square cos square theta plus u square sin square theta. Now we expand this paragraph, this bracket, plus g square t square minus 2u gt sine theta, and u square cos square theta plus u square sin square theta becomes u square, so it becomes under root u square plus g square t square minus 2u gt sine theta. So this is final velocity, resultant velocity of the particle at any point of the projectile path, and or we can say that in projectile motion. Now we will discuss the components in horizontal and vertical direction, and the components are, first we discuss about from horizontal. So the components of horizontal, in horizontal direction, number one, range, that is represented by R. This is the component in horizontal direction. Second, we will determine component velocity along horizontal direction after time t. This is the second component in horizontal direction which we will determine. And third, horizontal displacement after time t. Similarly, we can determine the components in vertical direction. So number one component is maximum height. Second component, time of flight. This is vertical component, time of flight. This is second component in vertical direction which we will determine. And third, time taken to reach maximum height. And number fourth, vertical displacement after time t. So these are the components, horizontal and vertical components, which we will determine during this lecture. So dear students, in horizontal direction, if we discuss about the horizontal velocity, that is Vx, as we have already discussed, Vx should be u cos theta. This is in horizontal direction. And horizontal direction. And acceleration in horizontal direction, it is always equal to 0. And velocity after time t, it is always equal to u cos theta. And horizontal displacement, if we discuss about the horizontal displacement, it should be after time t. So it should be, suppose this is x, it should be velocity, horizontal velocity into time, horizontal velocity u cos theta. And if suppose time is t, this is the horizontal displacement after time t. And if we will discuss about the vertical direction, so velocity in vertical direction, it should be u sin theta. Acceleration always equal to minus g in vertical direction. And velocity after time t, it is again u sin theta, but we know that V equal to U minus GT. As we have calculated, it should be U sin theta minus GT. If time is involved, then it becomes U sin theta minus GT. And vertical displacement. Vertical displacement after time t. It should be, we know that h is equal to ut minus half gt square, and we can consider h is equal to u is u sin theta into t minus half gt square. This is vertical displacement after time t. And velocity at height h. Velocity, if we have to calculate the velocity at height h after time t from the surface, from the surface. So we know that v square equal to u square minus 2gh, and we can take it vy square. This is uy square minus 2gh at height h. So vy equal to under root uy. This uy is u square sin square theta minus 2gh. So this is velocity in y dimension, velocity in vertical direction. So suppose we have to calculate the velocity at point xy. At projectile path, we have to determine the velocity at point at this coordinate xy. So it should be under root, v should be under root vx square plus vy square. We know that vx and vi both are perpendicular to each other, so it should be under root vx square plus vy square. And suppose this is vx and this is vy. So this angle is alpha, direction angle of resultant from horizontal. Suppose it should be alpha. So tan alpha equal to vy upon vx. So this is tan alpha. It should be vy upon vx. And if we determine the displacement, it should be s equal to xi plus yj. We know that, and s should be under root x square plus y square. This is the magnitude of s. Suppose this is projectile path, and we are discussing about this point, and coordinate of this point is xy, and this angle is beta. So this distance, it should be x, and in y dimension this distance, it should be y. So tan beta in this projectile path, it should be y upon x. Now we want to determine the equation of trajectory path. So we know that x, it should be velocity ux into t, or we can say u cos theta into t, and we know that y is equal to uy into t minus half gt square, or we can say uy means u sin theta into t minus half gt square. This is y. And we also know that y is equal to u sin theta. This t, we can write this equation, t is equal to x upon u cos theta. So it becomes x upon u cos theta minus half g, t means x upon u cos theta square. This is t square, and it becomes u cancel out, x sin theta upon cos theta minus half gx square upon u square cos square theta. Or we can write it x sin theta upon cos theta. It becomes tan theta, x tan theta minus half g x square upon u square cos square theta. This is y. And here y to the power 1 and here x to the power 2. This term represents that this equation is an equation of parabola. Equation of parabola. So we can say that the path of projectile should be parabolic. It should be parabolic. So if we have to prove that what is the path of projectile motion, then we can say that we can prove that the path of the projectile motion is parabolic. Now we can write it y is equal to, we can take it x tan theta common, x tan theta. If we take common, then it becomes 1 minus this x tan theta, 1 minus, this is minus half g x, we can take x common, upon cos square theta tan theta. We have taken x tan theta in outside from the bracket, and x tan theta, it becomes 1 minus gx upon, we have forgotten u square, 2u square cos square theta, tan theta is sin theta upon cos theta, 1 cos theta is cancel out, so it becomes sin theta cos theta, and 2 sin theta cos theta is sin 2 theta. So x tan theta, we can write 1 minus gx upon u square sin 2 theta, and we can also write it y equal to x tan theta 1 minus x upon u square sin 2 theta upon g. G we can take in downward, so x upon u square sin 2 theta upon g, and dimensionally the unit of this u square sin 2 theta upon g should be the equal to the unit of x. So we can represent it by r, u square sin 2 theta upon g, and this r is known as range. This r is known as range. Range means this is projectile path, initial point, final point, horizontal path covered by the projectile particle, that is range, and it should be u square sin 2 theta upon g. This is r. Now we will calculate the maximum height of the projectile. Maximum height of the projectile. So maximum height is, it should be We know that v square equal to u square minus 2gh, and in projectile path, as the particle is moving in upward direction, the component in upward direction will be decreased continuously, and at the maximum height Vy becomes equal to 0. So it becomes Vy square equal to Uy square minus 2gh, and Vy should be equal to 0. So it should be 0 equal to Uy square minus 2gh, and Uy square equal to 2gh, and h should be Uy square upon 2g, and Uy should be u square sine square theta upon 2g. This is the height. This is the height of the projectile, which depend upon the initial velocity u, theta and g. Now we will determine the time of flight. Vertical component, time of flight. So time is t is uy upon g, u is equal to gt. We know that during projectile v is equal to u minus gt. At highest point, final velocity becomes 0, and it is uy minus gt. So uy is equal to gt, and t is equal to uy upon g, or we can say uy is u sin theta upon g. This is a time of a projectile from initial point to highest point. This is time from initial point to highest point, and that is the time from highest point to final point. So time of flight is t. Time of flight, the time at which the projectile or particle remains in air. So it should be twice into t, or we can say 2u sin theta upon t. This is the time flight which we use to solve the problem of the projectile. Now we will calculate the range. Some discussion we have done here. This is range, and basically range is the horizontal distance which is covered by the projectile. Already we have discussed about this, and technically it should be horizontal velocity into time of flight. Time from this point to this point. This is time, and velocity in this direction, it should be ux, that is u cos theta. So basically range should be horizontal component of velocity and time of flight, means u cos theta into time of flight is 2u sin theta upon g, or range should be equal to 2 sin theta cos theta, it is sin 2 theta. So u square sin 2 theta upon g. This is range. U square sin 2 theta upon g. First, earlier we have determined this is range. U square sin 2 theta upon g. Here we can see that if a projectile is projected at angle theta, then range should be r. And suppose it is projectile at 90 minus theta, then r should be u square sin 2 theta is 90 minus theta and upon g. So range becomes u square sin 180 minus 2 theta upon g. Sin 180 minus 2 theta is sin 2 theta. So it is u square sin 2 theta upon g. and it is equal to the projectile which is projected at an angle theta. So if we project a particle or body at 90 minus theta, the range should be equal to the particle when the particle projected at an angle theta. So the range when the particle is projected at an angle theta and when the particle is projected at an angle 90 minus theta remains same. This is the first technical point of the range. Second technical point, if theta equal to 45 degree, then range should be u square sine 2 into theta 90 upon g, and sine 90 is 1, maximum value of sine. So range is u square upon g, which would be the maximum range. This should be the maximum range. So we can say that when the particle is projected at an angle 45 degree from the surface of earth, then the range will be the maximum. This is second technical point. And third technical point for range, it should be, we know that r is u square sine 2 theta upon g, and r maximum, as we know that r maximum equal to u square upon g, or we can write uy square upon g, as this is the vertical component of velocity. And if we see the height, maximum height, we know that it is u square sine square theta upon 2g, or we can write uy square upon 2g. So we can say that this is h maximum. H maximum, maximum height, it should be the r maximum, maximum range upon 2. This is the relation between height maximum and range maximum. So this is the maximum height. Now we will determine the change in momentum. Suppose this is a projectile path and particle is starting to move from this point A, initial velocity ui, this angle theta, and we know that this component is u cos theta and this component should be u sin theta, and we know that ui should be u cos theta eta plus u sin theta j. Okay, and at this final point B, this is final velocity and component, again it should be u cos theta and it should be u sin theta. So in opposite direction, so uf, it should be u cos theta eta minus u sin theta j. So if we determine the change in velocity, it should be uf minus ui. Uf means I u cos theta minus j u sin theta minus u cos theta I minus u sin theta j. I u cos theta I cancel out, u cos theta, so it becomes minus 2u sin theta j. This is change in velocity, minus 2u sin theta j. Now change in momentum, we know that momentum is mass into velocity, so change in momentum, it should be delta p equal to final momentum minus initial momentum, or we can say m uf minus ui. So delta p equal to m uf minus ui, we know that we have calculated above, minus u 2u sin theta j, and change in momentum is twice mu sin theta j. This is the change in momentum during the projectile path. Now we will calculate the velocity at the highest point, and we know that it should be uf, and it should be u cos theta into I. We have already discussed that when the path at highest point, this component is not exist, only this component is existing, so it is I u cos theta, and we can say that m u cos theta I. This is momentum at highest point, and at initial level, momentum should be m u cos theta into I plus u sin theta j. So change in momentum at highest point with respect to the initial point, it should be the pf minus pi. We can represent it by delta p, m u cos theta I plus u sin theta j minus u cos theta I. This is pf minus pi. So it should be plus and it should be minus. So it is cancel out, and change in momentum becomes minus m u sin theta j. This is change in momentum with respect to the highest point and initial point. And if we calculate the kinetic energy at highest point, it should be half m v square, half m v f square, or uf square. We know that uf is u cos theta, so kinetic energy at highest point, it should be half m u cos theta. There is no requirement of eta, as kinetic energy is scalar quantity, so it can be written half m u square cos square theta. Half m u square is initial kinetic energy, so final kinetic energy at highest point, it should be initial kinetic energy into cos square theta. This is the kinetic energy at highest point. And suppose an object is thrown from the window of a moving train, then the path of that object will be the projectile. Now the next case is horizontal projection. Suppose the object is projected at a height h. In previous cases, the object is projected from the surface, and reaching point, destination point is again at the surface. But right now, the object is projected at a height h, and now the path of the project should be just like this. And in this condition, it should be the direction of the initial velocity should be like this, and at any point, this is the direction of u. It should be gt, and it should be the direction of resultant velocity v, and v should be under root square of this u square plus square of this g square t square. This should be the resultant velocity. And now range should be this, from this point to this point. And if we see the components in horizontal direction, initial velocity we have considered u, initial velocity u, and after some time initial velocity u, and after some time velocity is also should be equal to u. Okay, we can consider it Vx, as we are considering the case of horizontal direction. And in horizontal direction, acceleration should be equal to 0. Acceleration should be equal to 0, and range, this range should be equal to velocity, initial velocity into time, u into t. If we discuss about the vertical direction, for vertical direction we can see that there is no vertical component of the velocity. So in vertical direction, ui becomes 0, ui equal to 0. But in horizontal direction, acceleration is 0, but in this direction, acceleration should be equal to the gravitational acceleration. So now the direction of gravitational acceleration should be in this direction. So in vertical direction, acceleration should be g, and in horizontal, initial velocity and velocity after some time, it is equal to u. Both are same. But in this case, velocity after some time, Vy becomes equal to 0 plus minus gt. Minus sign represents the direction of the velocity should be in downward direction. And if we calculate the displacement, so it should be v square equal to u square minus 2gh, and if we take it vy square, it is 0. So 0 minus 2, it should be minus g, and it should be minus h, or we can write 2gh. And h, vy should be under root 2gh. This is velocity at a height h. Velocity at a height h, and displacement should be y is equal to half gt square, u equal to 0, h is equal to y is equal to ut plus half gt square, y equal to half gt square. So if in this case, if we discuss about the trajectory equation, in previous case we have also find the trajectory equation. In this case we again determine the trajectory equation, and trajectory equation should be, we know that y is equal to half ut minus half gt square, 0 minus half gt square. Suppose this is the direction of vx, and this is the direction of vy, and this is the direction of resultant velocity, and this is angle alpha. Now y equal to minus half g time should be equal to x upon velocity, so it becomes x square upon u square. This equation represents the equation of trajectory path. Equation of trajectory. Equation of trajectory. If we want to determine the time of flight, we know that in previous case we have discussed the time at which the object is in air, that is time of flight, and in this case we know that it should be h. We can determine by h equal to ut minus half g t square, and in this case h should be minus h, it should be 0 minus half gt square, and minus plus twice h equal to gt square, and t square should be twice h upon g, and t should be under root 2h upon g, under root 2h upon g. Range of the particle, in this case it should be ut plus half at square. U should be x component, horizontal component, time flight plus half horizontal component square root time flight. This should be the range of the particle in this case. Now we will discuss the last case in which projectile motion in inclined plane. This is a case in which plane is inclined. In previous we have taken the plane horizontal, absolutely horizontal, but in this case we will take the plane inclined just like this. This is inclined plane, and suppose this is the angle of inclination, and in this case we know that g should be in downward direction. If this angle is beta, then horizontal component of g, it should be g cos beta like this, and this component it should be g sin beta. This is a component g cos beta, and this is a component g sin beta. So acceleration has two components, g cos beta and g sin beta, due to the inclination of the plane. So now acceleration, x component, horizontal component, it should be minus g sin beta. Horizontal component should be minus g sin beta, and vertical component should be minus g cos beta. These are the changes in case of acceleration when plane is inclined. And in case of velocity, ux should be u cos alpha, and uy should be u sin alpha, where alpha represents the angle of resultant velocity. This is alpha, angle of resultant velocity from the horizontal. And if we, in this case, if we determine the time of flight, if we want to determine the time of flight, so time of flight, it should be, we know that s equal to ut plus half at square, and time of flight means time of object in air. So we should take the y component of all the component. So sy, there is no sy, it should be 0, and y should be u sin alpha, t plus it should be ay should be minus g cos beta. It should be minus g cos beta into t square. So g cos beta t square, it should be equal to u sin alpha t. And in this case, we can take t into g cos beta into t minus, this is alpha, u sin alpha equal to 0. So one case is t equal to 0 and another case is g cos beta into t equal to u sin alpha. So t is equal to u sin alpha upon g cos beta. And time of flight, we know that time of flight is twice of t, small t. So it becomes 2u sin alpha upon g cos beta. So in case of inclined plane, this is time of flight. And similarly, we can calculate the range. Similar component which we have already determined. Only method of the determination may be different, but we have the same components. So range should be, we know that R, that is S, and range is horizontal component, so it should be uxt plus half axt square. X component, horizontal component of u and x, u and a are equal to ux. Ux means u cos alpha into t minus half. Ax means g sin beta into t square. And similarly, in if we take the case of downward inclined plane, and this case show the slight different result. Suppose this is the inclined plane and this angle is beta. Suppose it represents y, it represents x, and object is projected like this. This is initial velocity. This angle is alpha. Component of the velocity should be u cos alpha, and in this direction it should be u sin alpha. And if we discuss about the g, then g should be like this, and component g sin beta should be in this direction, and g cos beta should be in this direction. This angle should be beta. So if we discuss the case, in this case ux should be u cos alpha in x direction, and acceleration should be g sin beta. This is g sin beta. And in y dimension, uy should be u sin alpha. This is this case u sin alpha, and ay should be g cos beta. This case g cos beta. This case. So we know that suppose this is a point P. This is a point P. So at point P, Vy equal to Uy plus Ay flight time, and Vx is should be Ux plus Ax into flight time, and T it should be 2Uy upon Ay, 2Uy upon Ay, or we can say 2U sin alpha upon G cos beta. Actually, we know that time of approaching the highest point, it should be U sin alpha upon G cos beta. So twice of the time approaching the highest point, that represents the time of flight. So 2U sin alpha upon G cos beta. And if we determine the range, as we have already explained that the component are same, only method should be different. Sx equal to uxt plus half axt square, and now we can put the value of ux and ax. So sx becomes ux is u cos alpha t plus half g sin beta t square. This is the range. And if we solve more, if you want to solve more, then we can put the value of t in the equation. So this should be the range, and one case may be u cos alpha 2u sin alpha upon g cos beta plus half g sin beta 2u sin alpha upon g cos beta whole square. This is also should be the range which we can represent it by R. So this is the case of inclined plane in which the object is projected in downward direction. So all the cases we have discussed in this video of projectile motion, and the practice problem we will do in the next video. In this video we have discussed the projectile motion at a horizontal plane, projectile motion from the height of the surface, projectile motion at the inclined plane when the object is projected in upward direction, and when the object is projected in the downward direction. These four cases we have discussed in this video, and all the conditions, terms and formulas we will use in practice problems. And now in second video we will discuss some problems related to these properties. Thank you very much. We will meet again in next video.